Okay, so today we're going to discuss a numerical example on computing the flexural stresses at various stages and comparing with the ACI limits for a class U member. So this is the this is the cross section of the given member. Okay, so these are the strands. Each of these dots represent a strand. Now this strand is itself composed of 7 wires and also known as 7-wire strand. Okay, so each strand is itself composed of 7 wires and there are a total of 10 strands over here. Okay, and the centroid, so these are all same diameter thick, so they have all same cross-sectional area each strand. So these their own centroid is at this level. Okay, जो center वाला level है. So the eccentricity of the pre-stressing force is at this level as compared to the centroid of the overall cross section. Okay, so the eccentricity, this is the E value actually. The eccentricity is 7.91 inch and this is constant. Constant means all over the span we have same eccentricity of 7.91 inch. Okay, so this given beam is a simply supported beam and has a span of 40 feet. These are the cross-section properties of this cross-section, geometric properties of this cross-section. Moment of inertia is directly given, 12,000 inch/4, and AC is the gross area of the cross-section, 176 inch square. Okay, the R square, what is R? Radius of gyration. Since in calculations we often require the term R square, so we have directly listed the value of R square. So just keep in mind that this is the R square is 68.2 inch square. Okay, it's not R. R is of course lesser. Okay, if you want to calculate, you can calculate by you can also calculate R from this relationship. Okay, R equal to I over A square root. Okay, but if it is directly given, you can use it. Otherwise, you can use this one directly. So S is also given 1000 inch raised per cube. Now, if you see that we are not given all the dimensions, we are only given these two the dimensions. We are given only two distances from the centroid to the extreme top fiber and from the centroid to the extreme bottom fiber. We are not given each dimensions in this case. We have been given the properties directly. Okay, so if you are given the section, you should be able to calculate these properties. These are basics. But if you are given these properties, you can directly use them. Okay, so section modulus is 1000 inch raised per 1000 inch cube. W naught, this is the self weight. Now if it is given, you can use it, but if it is not given, what you can do is that if you know the cross sectional area, okay, if you know the cross sectional area, you can calculate the self weight, okay, by using the density or the unit weight. Okay, now in US customary system, the unit weight is 150 pound per foot cube for reinforced concrete members, and if you multiply this by 176 inch square over 144, okay, so you get this to foot square. Okay, make sure you convert it to foot square before you use it. Okay, so now you can just calculate. This would be around 183 pound per foot, which is 0.183 kg per foot. Okay, so if you are given the value, you can use it. Otherwise, you should be able to calculate these properties. Now this is the superimposed dead and live load together. You are given the summed up value of dead load and live load. This is this is in addition to the self weight. Of course, self weight is a dead load, but apart from this self weight, the beam has to carry superimposed dead and live load of 0.750 kg per foot. This is the service load. Okay, in addition to the self weight. Now, percentage of the live load which is considered sustained is 100%, which means all of the live load is being considered as sustained load and there is no short-term part of it. Now, the initial pre-stress force will be 158 kips at the time of transfer. This is not a jacking force, it's the force transferred to the member initially. Okay, 158 kips. Now after losses, the effective pre-stress force will be 134 kips, okay, reduced. Now the concrete strength at the initial stage when the pre-stressing will be done, it will be 375. This is the specified value, 3750 psi, okay, and the specified concrete strength at 28 days is 5000 psi. What we are going to do is we are going to calculate the flexural stresses at various stages as the loads are applied, and we will compare them with the corresponding limits for a class U member, uncracked member. Okay, so let's get started with the first phase. I've listed the loads slash limits on this column, and I'll calculate the stresses at the ends and mid span. Okay, and then at the ends and mid span, I'll be calculating the top and bottom stresses. Okay, so this is already F2. Now, starting with this PI, so the stresses due to PI will be, since we have provided same eccentricity, constant eccentricity throughout the span of the member, therefore it will be same result for both the ends of the member as well as the mid span. Okay, so let's calculate this at due to PI. The stresses are calculated like this: F1 equal to, we derived this expression last time using the basics. Okay, so minus Pi over AC into 1 minus EC1 over R square. Okay, so now you can just put the values minus. Now Pi is 158 kips. Now I have decided that I would work in pounds and inches, so that the stress when calculated will be in pound per square inch, psi. Okay, so wherever you see feet, you convert them to inches. Wherever you see kips, you convert it to pounds. Okay, so therefore I will use 158,000 pounds over AC is 176 inch square into 1 minus, now eccentricity is 7.91 for both midspan and ends, 7.91 inch. And what about C value? C1, this is C1, okay, distance from the centroid to the extreme top fiber. Okay, C1, this is actually C1, and this is your C2. So these are calculations for the top. In this case they are same, but if they are different, you should make sure that you use the corresponding values. Into 12 divided by R square, which is 68.2 inch square. Now you can get the answer. Okay, you can see what the answer is. Okay, so we can round it off to 350 plus 352 psi. Now it is important to mention the plus because you want to reinforce that it was a tensile stress. Okay, so it's a tensile stress at the top due to Pi. Now you should list it down over here, plus 352. Okay, now what about the bottom? You will use the same expression with, except that this is now C2. Okay, oh, I'm sorry, this is also different. This is plus over R square. Okay, so minus 158,000 over 176 into 1 plus 7.91 into, if eccentricity is different for ends and midspan, you have to do the calculation separately for the ends and midspan using the corresponding E value. For this case it is constant, into 12 over 68.2. so what do you get? Please keep verifying the calculations because Sometimes the book can contain errors. So what's your answer? Minus 2147 psi. This minus sign tells that it is a compressive stress. All right. Now let's enter this value over here, minus 2147. Okay. Now we're done with the calculations for the ends, and same calculations will be entered for the midspan because we have same eccentricity for the ends as well as midspan. So we'll just replicate that. Plus 352 and minus 2147. Okay, so we're done with the PI stage. But what happens is, as soon as you impart pre-stressing to the member, it just lifts up from the platform, and what then happens? Self-weight is activated. So you need to account for the fact that self-weight will start acting as soon as you apply the initial pre-stress force. Now, that self-weight is a simply supported member. That self-weight, will it produce any moment at the ends? No, it's a simply supported member. Okay, so if you just see, if it is a simply supported member and if you apply a uniform load onto it, the moments at the ends will remain zero. If the moments are zero at the ends, which means the stresses will also be zero, the flexural stresses will also be zero at the end. So no effect at the end. So you will just replicate these numbers from the previous row. Okay, and for the midspan, we need to account for the fact that let's first calculate the moment due to this self weight. This self weight is 0.183 kips per foot. Now you would know that the bending moment distribution goes like this, which is W L square by 8. In this case, we would say W naught L square by 8. So this moment due to self weight is, W naught, which is 0.183, L is 40 square by 8. Okay, so you can see the answer would be 36.6. Now take care of the units, feet and kips, feet kips. Okay, now as we decided to work only in pounds and inches to get the answer for stresses in pound per square inch psi, we would use these numbers accordingly. Okay, so we have the m naught value over here. Now the stress, so the self weight. Okay, let's calculate the stresses solely due to self weight, and then we will do the superposition accordingly. Now self weight produces stress. So the moment was 36.6 kip foot, and now the stresses due to this would be, now you can understand that the self weight will produces tension at the bottom and compression at the top. Okay, so at the top should see compression. Okay, so minus m naught over s. I'm using this minus because I know that at the top it will produce compression. Okay, so this is giving me the numerical value, and this is taking care of the sense. Now m naught is 36.6 kip foot, so I will multiply this number by 1000 to make kip 2 pounds, and fit I'll use 12. So this is now, moment is in pound inch now. Okay, so this is in pound inch now, and s is, maybe I can write it down over here, pounds into inches, and s is already in inch cube, so 1000 inch cube. So you can see we will end up with pounds over inch square, which is psi. Now you can see this number is 439 with a negative sign to account for the fact that it is going to be compressive at the top, and at the bottom we'll just use the same number with a different sign, plus 439 psi. Now we have to consider the superposition over here because PI produces some stresses and self-weight produces some stresses. So we'll just do the superposition over here. So plus 352 superimposed with minus 439. Okay, minus 439 to get what do you get? Minus 87. Okay, and what about this bottom? You get minus 2147 plus 439 to get, what's the answer? Minus 1708. Okay, so we have done the calculations for this stage. Now this is where these are the stresses for which we have certain limits. Okay, these are the stresses for which we have certain limits by ACI. Now let's come to the table 22.1, I think. Table 22.1. If you don't have it in printed form, you can just pull it from your mobile screen. So table 22.1 in the book, yes please. Yeah, all of it is in compression. One side is heavily compressed, the other is just a little bit of a compression. So yeah, at the end of, so we don't have a neutral axis in this superimposed stage. Okay, if I can just plot them over here for you, it looks like this. If I can see, where should I plot the compression? Let me just follow the book's convention. So, and they are plotting compression on which side? On the right side. Okay, so this is minus 87 at the top, and at the bottom we have a big line to represent a much heavier stress. This is what the stage is, minus 87 and minus 1708. This is because the this stress was, minus 2147 was a big number for the self weight to counter. Self weight is making a little bit of a difference. So yeah, it remains compression all over the section, and compression good for concrete. Okay, so but this is only happening at the midspan where the self weight can have some effect, where at the ends we have some tension at the other end, at the top, and some compression at the bottom. Okay, there you have a unique neutral axis where your zero stresses exist. So no surprise, you can have all compression in case of pre-stressed members at certain stages. Now let's come to the limits. Please go to the table 22.1. Okay, please go to the table 22.1. Now look at the conditions. A says, have you got the tables? So you should be looking at your mobile screens. That's where the table is, I think. So what does A say? Extreme fiber stress in compression immediately after transfer. Okay, so this is where we are looking at A. Extreme fiber stress in compression immediately after transfer, except as in B. Now, what I want to ask you is, we've got these four stresses, okay, top, bottom, where that limit applies. Like, we have a limit from A, okay, तो वो इनमें से किसके लिए लिमिट है? Okay, this is something you need to understand. Extreme fiber stress in compression immediately after transfer, except as in B. And what does B say? Extreme fiber stress in compression at ends of simply supported members. It means for ends we have different clauses. For other than ends, which happens to be midspan for this case, for midspan we have different classes. Okay, so you should see that the part A, condition A, B, C, and D. Now, this is related to compression, okay, and this is related to C and D are related to tension. Okay, they are related to tension. This is compression. Okay, so although it doesn't mention midspan, but in this case we have the midspan. Okay, at the ends there is a separate clause. Compression at the ends, there is a separate clause. Okay, tension at midspan. Okay, there is a different limit, and for tension at the ends we have different limits. Okay, so let's first do maybe the ends. Okay, let's write down maybe the limits for the ends. Okay, so we would look at this one and this one. Now at the ends, now what are these limits? This one says, let's go to the tension first. This one says it should be, the limit is 6 under root of FCI prime. Okay, so what does it say? This is in the extreme fiber stress in tension immediately after transfer at the ends of simply supported members. Okay, so the extreme tensile stress that is allowed is given by this. Can you just calculate this number? Keep in mind this is FCI prime, which means we are talking about the specified strength of concrete at the time of pre-stressing, not the full 28 days strength. Okay, so make sure you use the corresponding strength 3750. So what do you get out of it? 367. Okay, so this is the limit. Maybe you can put a plus sign over here just to reinforce that it is something related to tension. Okay, PSI. Now sorry, what was the number? 367? Now, for the ends, again, the compression limits given and stated in B is for uncracked member. We are looking at the limits for uncracked member. It is 0.70 FCI prime. Now you can just do the calculations. 3750, and what is the answer? 2625. Can anybody else confirm this? Let's put a negative number over here just to reinforce that we're talking about limits for compression. Okay, all right. Now for the midspan, okay, now let's put these numbers over here. Maybe you can just write them down over here. Compression at the ends, the limit is minus 2625, and tension, the limit is 367. Okay, good enough. The currently produced stress at the ends, the tensile stress at the ends due to pre-stressing is 352, and the limit was 367. Okay, so this is good, within the limit. Okay, maybe you can put something that relaxes you. Okay, so you can just go ahead. Okay, this is okay. And what about the next one? Maybe you want to put the okay over here, or maybe that one, because you're just saying this is okay because it is lower than the limit. All right. Now, what is this? What does it say? Minus 2147. Okay, minus just tells you the compression, and this minus is also telling you the compression. Now, the maximum compression allowed is 2625, and we have lesser than that. Okay. Okay. What is next? At the midspan, compression at the midspan, the limit is 0.60 FCI prime. Okay. So what is the answer for this? Maybe again we can put a negative number over here, negative sign. What's the limit? What's the value? Sorry? 2250 with a negative sign to tell that it's compressive. And what about the tension limit? It is 3 under root of FCI prime. Okay, so 33750 under root 183, just half of this limit, which is for the ends. Okay, 183 psi. All right. Yes. Wow, good question. Well, yeah, we'll come back to this one once we finish the table. Okay, good question. So let's put the numbers over here, -2250 for this one. Okay, maybe you can use black. -2250. And what about the midspan? 183. Now let's try to understand this. The limit says that, okay, let's read the condition. It says extreme fiber stress in tension immediately after transfer. Extreme fiber stress in tension immediately after transfer is 3 under root of FC prime, which happens to be plus 183. So this is the limit for extreme fiber stress in tension, and we are having what? A compression. So is that okay? Of course, that's okay. So what does it say? If there were any tension produced over here at the top, at this stage, it should not exceed this 183. Well, we are saying there is no tensile stress at all. Okay, so okay, it is even a compressive stress. So it's obviously okay. -187 psi, no problem at all. Okay, getting the limit? समझ आ रही है कि हम कह रहे हैं अगर टेंसाइल स्ट्रेस यहाँ प्रोड्यूस हो, फॉर एग्जांपल लेट्स से यहाँ पे 150 psi टेंसाइल स्ट्रेस प्रोड्यूस हो, तो हम कहेंगे ये 150 psi का स्ट्रेस इस लिमिट से बढ़ना नहीं चाहिए 183 के टेंसाइल स्ट्रेस से. ठीक है, ये हमारी लिमिट है. तो अगर वो टेंसाइल है ही नहीं, अभी कंप्रेसिव है, तो मसला ही कोई नहीं. ओके, ऑलराइट. सो similarly, for this one, it is rather straightforward. The limit is 2250, and we are having 1708. So that's okay. Okay, you can just put those okays over here, so you can just relax and go to the next part. Now, well, why do we have different limits? Let me just write down the limits over here for you, so you can just quickly compare them over here. This was 6 under root of FCI prime, okay, and this was 3, and 2625, this was 0.70 FCI prime, and this is 0.60 FCI prime. Okay, so as far as the tensile stresses are concerned, we have more strict limits for, I'm sorry, we have slightly relaxed limits for this case and somewhat more strict limits for this case. Okay, so we are saying we will allow 367 psi at the ends, but for midspan, we won't allow anything above 183. Why? Because at the midspan, there will be some compressive stresses superimposed with the tensile stress due to pre-stressing, and the number will definitely be reduced. Okay, what I can say is, if this is the cross section, this